Number 4 wants us to graph an absolute value function. So when I'm graphing an absolute value function, normally an absolute value function looks like a V right in the middle of my graph, something like that. This one is going to have some shifts to it because it has the adding and subtracting. So when I do this one, let me clear out my absolute value, go back down to number 4. The first thing I have to do is figure out where is the middle of my graph. How did it shift? So I'm going to look at this part with the x. If x plus 4 equals 0, then x has to equal negative 4. That means my graph shifted backwards 4 places. But when I'm making my table, that means that's going to be my middle point. Instead of being at 0, it's now at negative 4. So when we graph, normally we like to put 2 points on each side because we're going to do something that looks like lines on both sides. So I'm going to fill in my table with the 2 numbers on each side of the negative 4. So negative 3, negative 2, and then negative 5, negative 6. So my 5 numbers are in order with the negative 4 being in the middle. Then what I have to do is I have to take each of those values, plug them into my original equation, and solve. So I'm going to start by putting negative 2 in there. 2 times the absolute value of negative 2 plus 4 minus 3. Well, negative 2 plus 4 is 2. The absolute value of 2 stays 2. So I have 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 is 1. Then I'm just going to repeat that for each of these numbers. So, doing the next number, getting rid of all that scribbling, I'm going to put the negative 3 in. 2 times the absolute value of negative 3 plus 4 minus 3. Negative 3 plus 4 is 1. The absolute value of 1 stays 1. So 2 times 1 minus 3. 2 times 1 is 2. 2 minus 3 is negative 1. Now I have to do my calculation with my next number. So I'm going to put the negative 4 in. 2 times the absolute value of negative 4 plus 4 minus 3. Negative 4 plus 4 is 0, because that was my middle one. 2 times 0 minus 3. Well, 2 times 0 is 0. I'm just going to get that minus 3 that was on the end. Now I'm going to put the minus 5 in. So, 2 times the absolute value of negative 5 plus 4 minus 3. Negative 5 plus 4 is negative 1. However, when you do the absolute value of negative 1, the absolute value changes it to a positive number. How far is negative 1 from 0? It's 1 place. So 2 times 1 minus 3. 2 times 1 is 2. 2 minus 3 is negative 1. Notice those 2 numbers match up. They should. Because when I do the absolute value of a negative, it made it a positive. You could probably guess what the next one is, but I'm going to work it out. 2 times the absolute value of negative 6 plus 4 minus 3. Negative 6 plus 4 is negative 2. The absolute value of negative 2, how far is 2 from 0? It's 2 places. So 2 times 2 minus 3. 2 times 2 is 4. 4 minus 3 is positive 1. Now keep in mind these are going to look at like a V shape. So I'm going to plot my points. Negative 4, negative 3. Over 4, down 3. Negative 3 is at negative 1. Negative 2 is at positive 1. Negative 5 is at negative 1. Negative 6 is at positive 1. So on Alex, they're going to make you draw 2 lines instead of just being able to click graph. You are going to click the ruler on the vertex and one of the endpoints, and you're going to draw your line from the vertex through that other endpoint. I've noticed sometimes if you stop right on that last dot, it counts it wrong. So make sure you keep drawing up because your line doesn't really stop. It keeps going up. And make sure you don't go below the vertex. Then you're going to put your ruler on the vertex in the other endpoint and again draw up and through there. And if I could draw straight, I would have something that sort of looks like a V. Right? and that would be the graph of my absolute value function. So number 5, again, wants us to graph the equation with an absolute value. We know it's going to look like a V shape. We're going to start with here so we can find what our middle x value is. If x minus 1 equals 0, then x would equal a positive 1. So in our table, 1 is our middle number. We need 2 points on each side of that. So I would have 1, 0, negative 1, and 1, 2, 3, right? So if I'm at 1, I go 0, negative 1, and 2 and 3, so I'm 2 points on each side of that. Then I'm going to plug my numbers in. So negative 2 times the absolute value of negative 1 minus 1 minus 3. A negative 1 minus a 1 is negative 2. However, the absolute value of negative 2 makes that positive 2. So negative 2 times 2 is negative 4. Negative 4 minus 3 is minus 7. Now for fun, because I know the bottom number should be the same as my top number, I'm going to hop down and do the bottom number, just to see if they match up. So I'm going to put the 3 in. Negative 2 times the absolute value of 3 minus 1 minus 3. 3 minus 1 is 2. The absolute value of 2 is still 2. Negative 2 times 2 is negative 4. Negative 4 minus 3, hey, sure enough, is minus 7. So if you're not sure if one worked out right, plug the other one in that you know should match up and see, do I get the same number both ways? I should. So now I'm going to go ahead and do the 0. So, negative 2 times the absolute value of 0 minus 1 minus 3. 0 minus 1 is negative 1, but it's in the absolute value, so it becomes positive. So negative 2 times 1 minus 3. Negative 2 minus 3 should be negative 5. Just for fun, I'm going to skip down and do the 2 to see if I get the same answer, which I should. So, negative 2 times the absolute value of 2 minus 1 minus 3. 2 minus 1 is 1. Absolute value of 1 stays 1. Negative 2 times 1 is negative 2. Minus that 3 on the end, sure enough, gives me that same answer of negative 5. The other one should be in the middle.
We have the meeting?
Oh, I forgot about that. I'll be up there in a minute.
Okay.
If I put my 1 in there, negative 2 times 1 minus 1 minus 3. So 1 minus 1 is 0. Negative 2 times 0 minus 3. Negative 2 times 0 is 0. 0 minus 3 is minus 3. I can then plot my points. So negative 1, negative 7, 0, negative 5, 1, negative 3, 2, negative 5, and 3, negative 7. This doesn't want to quite draw exactly where I want it to, but again, you're going to draw 2 lines from the vertex through the end point, and then the other line from the vertex through the end point, and you have your absolute value function. Notice this one goes upside down because I had a negative leading coefficient. If my leading coefficient is positive, it should go up. If it's negative, it flips upside down. All right. Number 6 on day 27, continuing on with graphing the absolute value equation that's going to look like a V. Again, we have to figure out where should the middle, the vertex of our graph be. So we're going to use the part in the absolute value, x plus 3 equals 0. If we solve that for x, x is going to equal negative 3. So if we do our table, we know the negative 3 has to be the middle value in our table. So negative 3, negative 2, negative 1, and negative 4 and negative 5 would be the 5 values we'd want to use in our table. And then just like when we graph everything else, we're going to plug our numbers in for x, solve to find our corresponding y values. So starting with the negative 1. 3 times the absolute value of negative 1 plus 3 plus 4. Negative 1 plus 3 is 2. The absolute value of 2 is still 2. 2 times the 3 in front is 6, and 6 plus 4 gives me 10. And then I'm going to do my next number. Since I don't have a lot of room, I'll erase and do the next one. So negative 2. 3 times the absolute value of negative 2 plus 3 plus 4. Negative 2 plus 3 is 1. Absolute value of 1 stays 1. Times the 3 in front is 3, plus the 4 on the end, going to give me 7. Then I'm going to do my next number. So 3 times the absolute value of negative 3 plus 3 plus 4. Negative 3 plus 3 is 0. The absolute value of 0 is still 0. 0 times the 3 in front is still 0. Plus my 4 on the end gives me 4. Plugging in my next number. 3 times the absolute value of negative 4 plus 3 plus 4. Negative 4 plus 3 is negative 1, but the absolute value of negative 1 is 1. 1 times the 3 in front is 3. 3 plus the 4 on the end, going to give me 7. That number and that number match up like it should. One last one for this problem. We are going to put negative 5 in for x, so 3 times the absolute value of negative 5 plus 3 plus 4. Negative 5 plus 3 is negative 2. The absolute value of a negative 2 becomes positive 2. 2 times the 3 in front is 6. 6 plus 4 is 10. Those two numbers match up like they should, so I can plot my points. So negative 1 is up at positive 10. Negative 2 is up at 7. Negative 3 is up at 4. Negative 4 is up at 7. Negative 5 is up to 10. And again, when we draw this, we're going to draw two separate lines, so we need to use the ruler tool. Click on the vertex and click on one of my endpoints. Make sure you draw from the vertex through that endpoint, and then click on the vertex and the other endpoint and draw from the vertex through the other endpoint, and you should have your absolute value function. So we'll be talking about shifts. Notice this one shifted back 3 and up 4. This made it shift back 3. This moved it up 4.